Today we are going to finish up in our solving equations flip book. So on that last page, multi-step equations with variables on both sides. So we've worked with multi-step equations, we've worked with variables on both sides, and now we're throwing that all together. So lots of different things going on with these problems. Okay? So again, being able to work through it step by step. What I want you to take a look at is in your interactive notebook, we also glued in a page, and so you might have to turn the page depending on how you have glued things in, that says steps for solving multi-step equations. So again, just some things to help you think through these problems. Okay? If there's any distributing to do, to work that out first. If we can combine like terms on one side of the equation, we would take a look at that next. Then we're eliminating one of our variables, so forth and so on. So it may be helpful on these problems to have your book open to that page as you work through your homework to continue to see that, what things do we look for first. So this first problem that we see, we don't have any distributive property to do. We don't have any combining of like terms that we can do. But yet this is a problem that we haven't seen before because we've got a variable b. We've got two different terms that have the variable b on the same side. But yet we can't combine them because of my fraction bar, which acts as that grouping symbol. So what would I be able to do to start working through problem number one? Anyone have an idea? So I've got this fraction bar, which is my grouping symbol. So instead of dividing, what do I need to do? I need to multiply both sides by, what is it I'm trying to get rid of? I'm getting rid of this denominator. Instead of dividing by b minus 3, I'm going to multiply both sides by b minus 3. So on the left side, I'm left with b plus 6. On the right-hand side, I'm going to go ahead and distribute this. So I'm going to be left with 2b minus 6. So now that I took care of that, this is a problem similar to the problems that we were looking at on Friday, variable on both sides. So just as we were doing last Friday, we want to start by getting rid of one of those variable terms. I like to get rid of the smaller one. So I'm going to subtract b from both sides. 6 equals b minus 6. Okay, if it helps you to put that 1 in front of the b to see 2 minus 1, okay, we just don't show it in our final answer. So I have 6 equals b minus 6. I want the b by itself, so I'm going to add 6 to both sides to find that b is equal to 12. So again, we need to process through working on both sides of the equal sign step by step. Then we're going to check our work. So we put that into the original equation. So 12 goes in place of the b. So I have b plus 6 over 12 minus 3 equal to 2. We need to check it and see what happens. So what's 12 plus 6? 18 over 12 minus 3 is 9, and 18 divided by 9 is 2. So 2 does equal 2, so I know I did that problem correctly. Number 2, what's the first thing I'm going to do in problem number 2? I'm going to distribute that negative 4 into my parentheses. So a negative times a positive is negative. So I distributed my negative 4 to the 2D. I now need to distribute it to the negative 3. So negative times a negative makes it a positive 12. I'm just going to bring down the right side. So again, now I've got a problem like what I was working with last week. Variable on both sides. I like to pick on the little guy, so I want to get rid of the negative 8d. And I do that by adding 8d to both sides. 12 equals 10d plus 11. So I got rid of one of the variables. I need that d by itself. So I'm going to subtract 11 from both sides. 1 equals 10d. So then I'm going to divide both sides by 10. So d equals 1/10. So when we check this one, it's going to have to think a little bit harder when we've got that fraction. In place of d, I'm putting the fraction 1/10. So when I do my check, I'm going to work one side at a time. So on the left side, inside my parenthesis, I need to multiply 2 by 1/10. How do I multiply fractions? How do I multiply fractions? What? No, don't use the reciprocal. We multiply straight across. How do I make the number 2 a fraction? 2 over 1. So if I multiply straight across, I get 2 over 10. 2/10 simplifies to 1/5. So I have 1/5 minus 3. What do I do to subtract with fractions? I need a common denominator. So instead of that 3, I'm going to make a common denominator of 5. So that gives me 15 over 5. So 1/5 minus 15/5 gives me negative 14/5. And then I need to multiply that with my negative 4, or negative 4 over 1. So I multiply straight across. Negative 4 times negative 14 gives me a positive 56 over 5. Now I'm going to work on the right-hand side. Logan, you sit up and stay awake, please. So on my right-hand side, I need to multiply 2 times 1/10, which just like on the opposite side is going to equal 1/5. I need to add 11, but I need a common denominator, so that makes it 55 over 5. So when I add those two fractions together, I get 56 over 5, just like I did on the left-hand side. So I know that that answer is correct. Problem number 3, lots of stuff going on here. Okay. So again, I just want to first look at one side at a time. So when I look just on my left side, I need to start with that distribution. So I get 4z plus 12, bring down the minus 4. Then just on that side, I can combine like terms. 4z plus 8. So just clean things up on the left side, much easier to work with when I just have 2 terms. Then on the right-hand side, I need to distribute the 8. So 8 times 1/2 z, what's half of 8? 4. So I have 4z, then I take my 8 times 1 and get plus 8. Variable on both sides, so I need to eliminate. So I subtract 4z from both sides, and what happened? My variable disappeared. So I've got one of those special solutions that we talked about on Friday. When the variable disappears, what I'm left with is a true statement. 8 does equal 8, which means my solution is what? Infinite many. Okay, infinitely many, or you can use all real numbers. Okay, infinitely many. If I would have had a false statement instead, for example, if it would have been 8 equals -4, what would my solution be? No solution. Okay, so important to be able to distinguish between those two special solutions when my variable disappears on both sides. This next one, we've got distribution to do on both sides. We're distributing a fraction. Okay. But because the numerator of our fraction is a 1, okay, if we multiply straight across, I'm taking 1 times the number that it's being distributed to, and then that's going to be over the number 3. So when I multiply by 1/3, that means I'm just dividing by 3. And when we think of it just as a division problem, it makes it much easier. So 9 divided by 3 is 3c. -18 divided by 3 is -6. -3c divided by 3 is -1c, or just -c. And then I have some simplifying that I can do. 3c minus 1c gives me 2c minus 6. The other option with working on the left side is I could have combined my like terms in my parenthesis first and subtracted my 9c minus 3c and got 6c minus 18, and then divided by 3, I'd still get to that same 2c minus 6. So that was just on the left side. Now I'm going to work just on my right side. Again, because my numerator is a 1, 1/4 just means I'm dividing by 4. So 12 divided by 4 gives me 3c, minus 28 divided by 4 is 7. So 2c minus 6 equals 3c minus 7. Want to eliminate a variable. I'm going to pick on the little guy. So subtract 2c from both sides. Negative 6 equals c minus 7. So I'm then going to add 7 to both sides and find that c is equal to 1. Now I need to check my work into the original problem. Because my c is going to be 1, basically that c is just going away because 9 times 1 is still 9. Minus 18 minus 3 times 1 is 3. On the right side, 1/4 of 12 minus 28. So if I combine my terms inside my parenthesis, 9 minus 18 is negative 9 minus 3 is negative 12. Negative 12 divided by 3 is negative 4. On the right-hand side, 12 minus 28 is 12 minus 28 is negative 16 times 1/4. So negative 16 divided by 4 is negative 4. Same thing on both sides of the equal sign, so it checks. So just lots of different things that we've looked through as we went through this flip book, just kind of being all thrown together. So when you've got lots of things going on, simplify each side of the equal sign and then use your steps to solving the equation.